Here we're going to look at some follow-up questions for the lesson. So first, find the domain if f of x is equal to the fourth root of 2x plus 5 plus 3. When we find domain, we're looking at restrictions or problem areas where when we plug in an x value, do we ever get a problem? Well, if we have a fourth roots are like square roots. You have to make sure that it's positive. You cannot take a square root of a negative. The plus 3 that's on the outside of the square root or the fourth root is a vertical movement. It affects it going up or down, so it has no effect on the domain because domain is left and right. So I just need to take the 2x plus 5 and set it greater or equal to 0. The index of the radical doesn't affect this at all. You just take the inside expression and make it positive. So this gives me 2x is greater or equal to negative 5. If I divide by 2, x is greater or equal to negative 5 halves. So the domain is negative 5 halves, comma, infinity. Now on part B, we have f of x equals the square root of x minus 6 divided by x plus 2 times x minus 3. So there's really two kinds of things going on here that have restrictions in the domain. First, the square root. So we need to make sure that for the square root, x minus 6 must be positive. So set the x minus 6 greater or equal to 0, and you get x is greater or equal to 6. Now second, you have a fraction. So with fractions, you cannot divide by 0. So you get restrictions from the denominator where you set those groups equal to 0 and you find those restrictions in the domain. So from the denominator, x cannot be negative 2 or 3. Now we have to figure out the overlap of these two restrictions in the domain from the square root and from the denominator. So the square root says x is greater or equal to 6, but it says x cannot be negative 2 or 3. So on my number line, I have negative 2, I have 3, but x must be greater or equal to 6. So this is giving me several different intervals here for the domain. I can plug in, if I try to plug in any number that goes to the left of negative 2, like if I tried to plug in negative 3, it would be okay on the bottom. I wouldn't get a 0, but on the top is where the problem comes. If I try to do negative 3 minus 6 under that square root, I get a square root of a negative. So even though plugging in negative 3 works for the bottom, it fails on the top. So I have to basically say, well, I can't plug in those numbers, and I have to go with this right here. X must be greater or equal to 6. So my domain here is x is greater or equal to 6 or 6 to infinity. For question 2, we want to come up with our own graph of a function where we want to make sure the domain is brackets negative 4 to 4 and range is brackets 1 to 2 union brackets 3 to 5. So with my domain, I want to make sure that it starts at negative 4 on the x-axis but stops at positive 4 on the x-axis, and it doesn't go beyond those points left and right. Now my lowest value in the range, it says from 1 to 2 and then from 3 to 5. Notice there's a gap in the range. So 1 to 2 is where the graph needs to start on the y. So let's go ahead and make a point B at aligning it with 1, but let's make it go to negative 4 and do a closed in circle there because you want it to be brackets. And the range for this piece is going to go from 1 to 2. So you can make it go up. It doesn't have to land at 2. But it could just maybe I can put a point at negative 1, 2, like that, and just do a little section of a graph there. Now I want to have a gap in the range. So I want to jump up to the range of 3. So jump up to 3, and let's kind of put a point above the point that I just did. So this point's going to be at negative 1, 3. And I want the height to be up to 5, but I want to end my domain at 4. So let's put another point over here at 4, 5, lock that in. And let's just connect. And you don't even have to do a straight line. You can make it kind of curve. Just make sure that you're not going to go beyond the restrictions on your height. So there's multiple things you could do to meet the restrictions for the domain and range for that graph. Suppose for some function g of x plus 3 equals 2x plus 1. Find g of negative 1. So here it's telling us to change all x's become negative 1s. And normally that just applies to the part after the equals, but we do have an x expression inside of the g of x part. So we actually need to first start there. G of x plus 3 becomes g of what plus 3? G of negative 1 plus 3. And that becomes g of 2. So we really are not plugging negative 1 in for the 2 times x plus 1 part. You have to plug it first into the g part, get that answer, and that answer goes into the expression. So 2 times 2 plus 1 is 5. So g of negative 1 equals 5.